Hello, my name is Alex Landis, and today I'll be covering radio communications and light gun signals. These are important because this is, especially for radio calls and such, we use that all the time in aviation. It's almost like the groundwork of all we do as pilots. There's a lot of communications involved with either ground, tower, dispatch, flight service, all sorts of agencies that we will talk to for communication. It's also important to know when to use radio in communications and how to use them for specific airspaces and stuff of that nature, and how to make calls and how to let other people know what you're doing, because often in aviation-related accidents, it's human error, and if we can allow each other to know kind of what's going on, that reduces the chance of these unsavory events. And also we'll talk a little bit about how or what we do when we lose radio communications, and that will take place kind of in the form of light gun signals, and how how we approach them, what to look for, and knowing what we're looking for and what it is telling us. So that is what we'll be covering today in light gun signals. So the first thing in terms of light gun signals, first of all, this would probably be introduced very, very early on, especially for a private applicant. A commercial applicant should be more than aware with at least the communication side of things. They should definitely be familiar with the light gun signals, but for sure they should be very, very proficient on the communication side of things. So for a private applicant, this could be something entirely new. Maybe I remember when I first flew and I listened to my instructor make radio calls when I was unable to at that early stage of my flying career. And there's a stage where it's like, I will never be able to do this. I will never be able to fully have a firm grasp on how this works. It just seems so complicated, when to call, what to say, what other people are saying. So it can definitely be daunting, and it definitely takes time, but after practice, a lot of practice, I would encourage a student, hey, it will come with time. We're definitely going to push you, but we're not going to necessarily cause you any distress in any way, but definitely pushing someone with practice is how we're going to get this, and just kind of communicating to them that it's a lot, but it'll come with time. And just walk them through it. And this is definitely not a lesson that stops at the lesson. It continues in practice, just like a lot of the other lessons, but especially in this lesson. So what we start off with is, okay, what kind of calls do we make? And the calls that we make in aviation and communications that we usually make are requests. We receive instructions based on the requests, and we confirm these instructions. So an example would be, you're outside of the Delta here at Lafayette, and we make our call at 10 miles out, Lafayette Tower, Purdue 55, 10 miles, let's say south, inbound for a full stop or for a touch and go or whatever we're trying to do, and with information uniform, or whatever the information might be. And that kind of comes off the cuff for someone who's really experienced. They don't necessarily need a template in their head. At least for me, it comes pretty naturally, but that's not to say that it always come naturally. As I said before, I never thought I'd be able to to run that out, right? But it just comes with time. But the template that we use for that, I like to go through. First of all, it depends on where you're at, right? So you got to understand a little bit about airspace, a little bit, and when you're in a controlled or non-controlled airport or situation, and you got to know kind of the environment around it. So starting off with controlled airspace, the template for our calls would be, who are we calling, who we are, where we are, what we want, and any additional information. So like in that call we were talking about earlier, say Lafayette Tower, right? Who you are, who you're calling, or who you're calling, who they are, right? Who you are, right? So Purdue 55, Purdue 56, Purdue 67, whatever it may be, whatever your tail number is, or your call sign, right? So it could be Purdue 65 or November 865 Papa Uniform, or That'd probably be more a non-towered airport, but you can also identify yourself as Purdue 65, or whatever the case may be. Where we are, right? So in this scenario, right, I can say, and I'll use this whiteboard behind me. I can say, so if I said, right, Lafayette's here, I said are south, right? So this is us right here. I can identify, okay, and we're making our call, right? So we're out here, we're making this call. We're saying, whatever we're saying. So again, who we're calling, so we're calling Lafayette Tower, who we are, Purdue 55 or whatever we are. And where we are, right? So we are south. We're south of the field, right? And it's important to understand where you are, because if you were to say, which is a common error, right? If you were to say Lafayette Tower from here, right? If you were to say that from here, Lafayette Tower, Purdue 55, 10 miles south, or north, that can cause, if Tower is complacent or they miss it or they just take us out of word, whatever the case may be, if we give them incorrect information, we're coming from the north, and they have someone else coming from the northwest, they're going to tell us, okay, they could say something along the lines of, it's pretty common, Purdue 55 report 3 miles south of Lafayette, right? And they could say something like that. Well, if we tell them report 3 miles south of Lafayette, and then they expect us to report here, and we report here saying that we're here, that could be a very, very dangerous scenario, because if there's someone coming in on this same fix or the same point or whatever it may be, this could cause complications, and it could disrupt the pattern, and maybe, in a very, very fatal case, I've never heard of this, but I wouldn't be surprised, this could cause a near mid-air collision, right? So understanding where you are is very, very important, right? And what do we want, right? So similarly, if we're going to come to a full stop at Lafayette, right? If we're going to come to a full stop, it's going to be important for Lafayette Tower to know that, right? For incoming traffic, right? For traffic trying to depart, right? If we're touching and going, that's going to take a lot less time than it is going to be for us to come to a full stop and taxi out for the runway, right? So ATC needs to know what our intentions are at the airport, so they can know what to do, so they can know how to direct other traffic, right? We're not the only traffic in the pattern. And it also gives them an indication of what's going on, right? They're able to have the foresight and see kind of what everything's doing based on where people are and what their intentions are, right? And then the other thing that we need to know, especially at a controlled airport like Lafayette, when we call in prior to making our 10-mile call, right? We'll get the weather. So, maybe it's important to get all the weather, of course, but especially for things like the altimeter setting is a really big one because that can play a role in our calculations and how to land and our approach and all those things. And if we have an incorrect altimeter setting, that can definitely cause us to maybe 200 feet high, or maybe not that drastic, but 100 or less feet high or 100 feet low in that unsavory scenario where we miss the runway or come into collision with other obstacles, right? We obviously do not want that. So stuff like the altimeter setting is very important. Also the winds. Now in a controlled setting, they're going to tell you where to land. They say, okay, they can either tell you what to expect prior to entering Delta, or they can just tell you once you get to your 3-mile point, right? Once you get to your 3-mile point, okay, make left base for runway 23, or make left base for runway 28, or whatever the case may be. They will clear us to do things. But in a non-controlled airport, we'll talk about this in a second, but that wind information might be more important because, remember, we're going to want to take off and land into a headwind, right? So gathering all that information, the last thing that we talked about, right? We talked about who we're calling, who we are, where we are, what we want, and the additional information, which is, okay, so again, who we are, or who we're calling, Lafayette Tower, who we are, Purdue 55, where we are, 10 miles south, right? And then what we want a full stop, touch and go, whatever it may be. And then with information, and then whatever the information is, information uniform, information alpha, information Gulf, whatever it may be, to let them know that we have all of the information and the weather characteristics that the most previous METAR has reported, right? Or the most previous ATIS, I should say. So those are the kind of the calls for controlled tower airspace. Now, non-controlled, similar, but a little bit different, right? So in a non-controlled airport, it's obviously not controlled. We're not going to have a control tower telling us what to do, right? We're not going to have an agency separating traffic. We're not going to have anyone directing, right? It's kind of the unicom frequency, right? So it's a bunch of different people are on this frequency and they're informing each other of where they're at, right? So when entering, it's vital because, first of all, it's vital in any airspace to state your intentions and to make all these calls, but even more so in uncontrolled airspace because while it's not technically required to make these calls, it is very, 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 can't emphasize this enough, encouraged to make such a call. So the questions or the statements that we're going to make entering uncontrolled airspace is a little different. So first, who we're calling, right? So it's still the same as in the controlled airspace. Who we are, still the same as the controlled airspace. Where we are, right? Same as the controlled space. Additional information. So we're not saying what we want, right? Because we don't have to be cleared for those things. We are going to do it, right? And obviously, we're going to determine based on the traffic, like if we can do it or not. We're not just going to do it with no regard to everything else going around, but we do not have to ask for it, right? So that's a difference between the two. And then in the end, after the additional information, right? So if we get the ASOS or AWOS or whatever it is at the Echo, or like say like at White County, we're gonna say with this weather, right? And then we're gonna end the call at the non-controlled airport with who we are calling, right? So it's important to say. So it's kind of like the calls at a non-controlled airport are a sandwich, right? It's the who are you calling sandwich, I like to say, where you have who are you calling at the front, who are you calling at the back. So the beginning and the end, you have who you're calling. So because these frequencies for airports that are uncontrolled cover a lot of different airports, right? It covers a region of airports. It doesn't necessarily just cover the airspace that you're entering, right? So if you're calling, you got to say White County, right? If we're entering White County's airspace, say White County at the beginning, White County at the end, because there might be someone at, say, Frankfurt or somewhere like that, where if they say, okay, Frankfurt traffic, yada, 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 Frankfurt, and we're at White County, right? Then we're like, okay, that traffic is not in the airport of our interest, right, if we're landing at White County. So it's important to state where we are because we're not controlled. We're not going to be told what to do, so we know which traffic that we need to be in communication with, which traffic we need to be on the lookout for, and things of that sort at a non-towered airport. So an example of a non-towered airport that we can walk through step by step again. So it would be White County traffic, Purdue 55, we'll stay with the south, 10 miles to the south with such and such a weather, White County traffic. Boom, right? So you state your traffic at the beginning and at the end. So again, people know who you are, and you walk through these things. And other than that, it's fairly similar to the controlled airspace. It's just understanding that you're going to have to be on the lookout for traffic. They're not going to say, okay, like they're not going to tell you. Let's say an example in a class Echo, when it's very, very busy, they're not going to say, okay, like extend downwind or extend base or whatever the case may be. They're not going to tell you what to do. You're going to have to determine that on your own. And in doing so, it's really, really important to keep track of all the traffic that's around you, right? If you have 2 or 3 people in the pattern, you need to know which people are where, right? So that's when you're in a non-towered airport. As you're, let's say, doing touch and go landings at a non-towered airport, you're going to state each leg of what you're doing. So you're going to say, when you land, Purdue 55, and then you're touching and go on Purdue 55 on the go for runway, I think at White County, I believe it's 18 and 36, right? So straight north-south, you're going to say White County traffic, Purdue 55 on the go for runway 18, right? and then you're going to get up, and then you're going to make a crosswind, and you're going to say, I said Lafayette traffic earlier, I believe. I'm sorry, White County traffic, Purdue 55 on left crosswind for runway 18, and then when you get to the downwind, you're going to say Lafayette, White County traffic. You're on the downwind, White County traffic, Purdue 55 on the downwind, on downwind for runway 18, right? And then base, final. You're going to make all those calls so that the traffic, especially when it's busy, knows where you're at, right? That is something that's very, very important to understand, that difference between a controlled airspace and a non-towered airport, right? And kind of how those practices work, and why. It's very, very important to understand. Other things at controlled airspaces, you're going to have frequency changes. You're going to have frequency changes between ground, tower, approach or departure, depending on what it is. So, for example, when we pre-flight the plane on the ramp, and we're at hangar 6, right? And we're sitting there, we got all the pre-flight going, we start the engine, we got our weather information, and then we make our call to ground, right? We say Lafayette ground, Purdue 55, on the ramp ready to taxi with information Bravo, right? Or whatever the case may be. In certain cases, you could say, if we're trying to get a flight following, we're going to need that frequency. You say requesting a flight following at the end of it. So like Lafayette Tower, Purdue 55, not Lafayette Tower, Lafayette Ground, Purdue 55, on the ramp, requesting a squawk code or requesting flight following, right? And then they'll say, and they might tell you to wait. They usually take a couple of seconds, and they'll come back and say, okay, Purdue 55, squawk 2245, or whatever the squawk code they assign you, and then you'll repeat back to them what that squawk code is, right? So if they say, Purdue 55, squawk 2215, you're going to say Lafayette ground, Purdue 55, squawking 2215, or whatever the case may be. And then it's also important to understand to taxi when they tell you, right? So if you're not cleared to taxi, don't taxi, right? Or if they say, and you got to really, really understand what they're telling you exactly, right? So this is important because at Purdue, right, we have this taxiway right here, Alpha, right? Alpha goes right through 23, right to 28, right? It's a taxiway, right? So if we're on the ramp and we're, let's say, here, right, we're waiting to taxi, we have to understand, right, if we're going to 28, or any runway where there's a crossing, intersection, wherever the case may be, we have to understand the taxi clearance requirements and the taxi, not clearance requirement, the taxi information they've given us. If they say Purdue 55, taxi runway 28 via Alpha, hold short of 23 at Alpha, right? That would mean, in this case, we taxi, and we get to Alpha, we stop right here, right? We are not going to cross runway 23 for whatever the case may be. It might be an active runway. That's the primary concern, right? If we cross a taxiway, or if we cross a runway on a taxiway while there's incoming traffic, that can cause all sorts of problems for all parties involved, right? We obviously want to stay safe and keep out of trouble. So when ground tells us to do something, we have to listen to it, we have to do it, and then we have to respond to it. We have to affirm to them that we heard. So if they say, Purdue 55, taxi to runway 28 via Alpha, hold short 23 at Alpha, we have to read that back. Lafayette ground, Purdue 55, taxiing to runway 28 via Alpha, holding short at 23 at Alpha, right? We have to let them know that we heard and we are going to follow their instructions, right? So it's always very, very important to understand what they're telling us, right? And then when we get to 23 at Alpha, we'll say, usually either before you get there or right when you get there, or you might have to wait a little bit. They'll say, Purdue 55, cleared across runway 23 at Alpha. And then you'll repeat back, Lafayette ground, Purdue 55, crossing 23 at Alpha, right? You say all those things, and it's always really, really important at these towered airports to let them know what you're doing, right? So that's communications with ground, right? and it's used for managing the vehicles on the ground, right? It's not designed to manage aircraft in the air traffic. It's just traffic on the ground. But still, following these things can affect air traffic, like we talked about earlier with landings and such. And it's still very, very important and vital that we understand what's going on ground. So at Lafayette, you need to be monitoring ground at 121.9. And at other agencies or other airports, we'll talk about more how to access those frequencies and those requirements. The next, what we need to know is air traffic control, right? So ATC, right? And tower, as we like to call it, right? So that's why when we came in, we didn't say, Lafayette air traffic control, right? It's technically correct, but as we say Lafayette Tower. So those are kind of used interchangeably, air traffic control and tower, right? So at Lafayette, that frequency is 119.6. And that is something, obviously, as you get more familiar with Lafayette, those frequencies should be memorized like the back of your hand. You should really, really, really know those frequencies. And at unfamiliar airports, those should be in a chart supplement that we'll talk about later. And important things to know about that is, again, like ground, when they tell us something, we have to follow it, and we have to read back what they are telling us to do. So, right? So let's say, again, I had the picture up there, I erased it, but let's say we cross, right? You have 2823 Alpha. This is us, right? We listen to them. They clear us the cross, right? We get here at 28 after crossing 23 at Alpha, right? And then we do a run up. We do all those things. And we make this switch to tower, right? And let's say we're holding short. We're at the hold short line of runway 28, and they tell us, Purdue 55 cleared for southeast, south departure, wherever, runway 28, right? We have to read back, clear for takeoff, runway 28, Purdue 55, right? We have to let them know which runway specifically we have been cleared for, so that for whatever reason they didn't notice that we accidentally mistook runway 28 for 23, and we take off of 23 as opposed to 28. That can cause all sorts of issues and complications, as we've previously stated, right? How understanding what we're told to do specifically is very, very important for the fluidity of the airspace as a whole, and for the safety of the airspace as a whole, in particular, right? So there have been several times where, Lafayette is obviously a student-heavy airport. There's a lot of students trying to learn how to fly, a lot of private applicants even, and people learning. I mean, I know that I did it as well. There's no shame, where we're all trying to improve as pilots. But you hear a lot of times, people say, clear for takeoff, Purdue, whatever they are. And Lafayette Tower, understanding this is a learning environment, is like, okay, like, you have to say clear for takeoff, runway 28, right? It's very, very important to state where we're taking off from. That is something that's very, very important with the tower, right? And then on cross countries and such, for the control agencies like departure and approach, we have these other frequencies for those services as well, right? So when we're on ground or whatever, and we tell them, hey, we're requesting a flight following, or when we tell them our intentions, they'll tell us, okay, like contact, typically around here, or always around here, I guess, contact Grissom approach at 123.85, right? That's our frequency for the approach around here, but it's also important to understand that handoff process. When you're cleared for that handoff to Grissom, in Lafayette's case, what to do and kind of how to do that, and of that nature. But something that's also kind of a side tangent, something that's very, very important, is when you make these frequency changes, right? If you make it from ground to tower to approach, or tower to departure, whatever the case may be, to understand that, and this is kind of a nuanced thing, this is something that is not necessarily a written rule, but it is something that will definitely cause a lot less frustration for the traffic and be a lot helpful for everyone involved, right? So when you make these frequency changes, something that's very important to understand is wait a couple of seconds. Wait a couple of seconds from changing the frequency to saying what you gotta say, right? Because last thing you want to do is say you switch from Tower to Grissom, right? And then you switch immediately, like boom. You make a perfect call. This is what I'm doing. This is where I'm at. You say who they are, who we are, what we want, all these things. But when you make that switch, and in that second that you make the switch and make the call, someone else might have been also in a situation where they are making a call, or they were communicating with Grissom, or all those things, and that can cause you to step on their call, is what we call stepping on a call, where that information is not be able to be relayed because you're spamming the frequency, right? You're on the frequency and you weren't aware of the conversation that was taking place. So a good rule of thumb is to always wait a couple of seconds at least from switching over between these frequencies, so that you understand the context of the conversations that are going around and you're not getting in the way of anybody. So that's just a good rule of thumb to have. Other frequencies that are important are the guard frequency, for example. So 121.5, we'll use this frequency in any emergency situation. It should be listened to on cross countries. ATC is always monitoring them, and that is the frequency that we'll switch to if we have an engine failure or anything in addition to our squawk code that we will switch, and we'll talk about in a little minute. But another frequency to be aware of is 121.5. That is a frequency that is very, very important to know in an emergency scenario. Flight service stations, right? So to pick up en route weather, to cancel flight plans, to activate flight plans, anything of that sort, it is very, very important to know the flight service station frequency, which is typically 122.2, but that is a frequency where you can pick up all your en route weather information and things of that nature. ATIS AWOS, we kind of talked about this earlier when we were talking about entering an airspace, right? A controlled airspace specifically, and actually definitely an uncontrolled airspace as well. But understanding the weather frequencies, right? Where to find them. Again, we'll talk about that in a second for those of us who are unfamiliar with them, right? Lafayette especially, and we should know 127.75, right? And just kind of what they do, right? ATIS, AWOS, they give us all the weather that we need, and it's important entering any airspace that we have those frequencies. And we do not transmit on these frequencies, right? You're not talking to the weather guy on the ATIS or ASOS or AWOS frequencies. We're not talking to anybody. It's either an automated or pre-recorded voice that gives us weather information that is important for our operations, right? So understanding those frequencies as well. And dispatch frequency. This is something that is definitely not at every airport, definitely not at uncontrolled airports. But we do have at Lafayette, and this can, for Lafayette, again, it's for Purdue uses specifically. When I was at Purdue Ave, flying around recreationally for fun, we don't use dispatch. But for Purdue operations, we do use dispatch at 123 or 123.3, right? And that is something like, hey, if you're in a flight slot and you're going to be back late, or you need to communicate something to Purdue, or more importantly, you're on the ground and you're trying to park, that is something we'll always say, when we get to those sheds right at the end of, I think, the Delta taxiway, I believe, and you say, dispatch Purdue 55 for parking or whatever. And then that's an organizational way for Purdue to be in contact with its fleet, right? So those are all frequencies that are very, very familiar and will be used on a day-to-day basis in Purdue operations in particular, and definitely for a vast majority of these frequencies in the broader aviation sphere as well. And how to obtain frequencies. You can obtain frequencies, I'm pulling out my iPad, in the CHARP supplement for the airport. So an easy way to do it, you just find a CHARP supplement on the FAA website, and I've already pulled it up and brought this up. But if you look, and hopefully this will clear up a little bit, you can see right here, you have all these frequencies, right? You'll have, hold on. Yeah, right here, you'll have Grissom approach, right? So those are your approach frequencies. Chicago Center, 123.8 as well. Lafayette Tower, you have frequency there. Ground frequencies. All your frequencies should be on the Lafayette Airport chart supplement, right? So understanding the chart supplement and where to find these frequencies. So let's say you wanted to go to a different airport and you didn't know their frequencies. Well, you just pull up the chart supplement for that airport in particular, and you would be able to find and distinguish these frequencies from viewing the chart supplement. I'll just say right on it what there is in communication for those airports and how to access them, right? And you can also access this data on sectional charts. In a sectional lesson, I would cover this thoroughly. I do not currently have a sectional on me, but usually right off of the airport, you'll have your ATIS frequency, your tower frequency, if applicable, right? Your Unicom frequency for the uncontrolled airports will all be located on your sectional charts. It'll also have all sorts of other things that I will leave to a sectional lesson. I believe I've already done one, so if you've had the privilege, of watching that, then you know that is something that has been covered, right? And G1000, we are very, very privileged to even be able to pull up these frequencies and these chart supplements on those devices, right? The G1000, ForeFlight, Garmin Pilot, sectional charts that we already talked about. That can even be given by ATC. If you have the ATC frequency, but for whatever reason you can't find ground, you say, how do I contact ground or anything of that sort, right? So you have all of these resources at your disposal to be able to obtain these frequencies. But most of them, or all of them, you could even say, are taken directly from the chart supplement. So understanding those things is very, very important, right? We already talked about ATC and reading back. We talked about must acknowledge, right? Those things we must acknowledge when we're taking off of 2A. We must acknowledge the instructions that are given to us, right? We must acknowledge the warnings, right? So another thing that's important is in a controlled airspace, they'll say Purdue 55, number 3 for runway 28, right? And you have to acknowledge that there's 2 other aircraft in front of you. If you're number 3, there's 1, 2, and then you, right? So acknowledging that those calls and those warnings, those traffic warnings, is very, very important, so that there's no confusion in what is asked and requested of us. And if there's ever a situation where you don't understand a call, you can always tell ATC, hey, I don't acknowledge, could you repeat, or whatever the case may be. It is better to be safe than sorry. It's not a good indication if you're a pilot and you don't understand what's going on, so you have this macho attitude of like, oh, it'll work out, I'll be fine, I'm a good enough pilot. We should always understand what is going on in radio communications in any type of airspace situation. Understanding what is being said, what is being transmitted is very, very important, right? There will also be, beyond warnings, there will be advisories from towers, right? They'll say, sometimes I'll have a wind check, right? It'll be wind at 270, 17 gusting 23, right? Or something of that nature. And for those things, that's just an advisory to all the traffic so they know, okay, this is the wind situation, right? This is what's going on at the airport. You don't necessarily need to respond to that. Or sometimes, if someone calls in, makes a PIREP, there's birds off the departure end of runway 28, right? Or something like that. Let's say, be advised, birds on short final for 28 or whatever. Just to let the traffic know it's an advisory, okay, this is happening, but you don't necessarily need to respond to that, right? And then we've already talked about frequencies when we have requests, things of that nature, Class D, Class C, and B. So the difference, particularly or definitely for B, is when we enter a Charlie or a Delta, right? We need to establish two-way radio communication, right? So that's for Fort Wayne, that's a Charlie, say, Fort Wayne Tower, Purdue 55, where we are. And then they have to, in order for us to enter that airspace, to acknowledge who we are. They don't have to clear us. They just have to acknowledge, okay, Purdue 55, whatever we said, right? They know who we are. That's the clearance to enter a Charlie or a Delta. The difference for a Bravo or a Class B airspace is that we have to be cleared, right? So they have to say, Purdue 55 cleared into the Bravo, right? You have to be cleared to enter the airspace. They can't just say, if you hear them say Purdue 55, that is not enough for you to enter their airspace. You have to be cleared into that particular airspace, right? So that's a huge difference for a Bravo airport that needs to be understood. Because if you enter a Bravo without being cleared to do so, that is a big no-no, and we definitely don't want to be doing that. There's some vocabulary that's important to understand in a scenario where I would know that I'm going to be teaching this lesson. I would probably assign reading homework for the student to go through vocabulary. I could find a link on the FAA website, or reading specifically in the PHAC or whatever the case may be of these abbreviations of these words that we need to understand, and give that homework to them so they'd be familiar. They would not necessarily sorry, I got a call on my computer. I apologize. They not necessarily need to have them all memorized or have everything down necessarily, especially for a private applicant commercial. Probably should already have this down, but just kind of understanding some of the vocab, like what a beam means, right? And I won't necessarily go into extreme detail on these things. I'll briefly touch on each one of these items, but I do not think it's worth the time when I could be using it on other things, and definitely will definitely become more and more comfortable with these words in practice in the air, right? So a beam. What a beam means, right? Like off your left or your right shoulder or whatever, 90-degree point off of whichever shoulder it is, a certain point. So usually at Lafayette, if we're in the pattern for runway 23, will be a beam 23 when it's off our left shoulder, right? The numbers are off our left shoulder or off our right shoulder, depending on how we're entering the traffic, right? Abort, we're terminating the pre-planned maneuver. We're no longer doing something, so we're aborting something, right? That is something that is important to understand. Advise intentions is how we're asking us, hey, what are you planning on doing, right? That's advise intentions mean. Affirmative, pretty straightforward. It means yes. There we go, buddy. Good job. Yes, that's what I said, or whatever the case may be. Clear for takeoff, also self-explanatory. It's when you, similar we talked about the Bravo, entering, we're cleared to the Bravo, we're cleared to take off. That means we have permission to take off. That is something that we need to be listening for at Purdue, for sure. Clear to land, obviously, also ATC giving us the clear to land. We're able to land, right? As prior, if we're not clear to land, we shouldn't land in a controlled airspace. But if we're cleared for that landing, we can land. Touch and go, clear for touch and go, self-explanatory. Clear for stop and go, clear for low approach, clear for the option, right? Clear for the option is a little different. So cleared for touch and go, self-explanatory, right? We can clear to touch and go, right? We can to land and then take off again. Clear to stop and go, clear to stop and take off again, right? Those are all self-explanatory, but clear for the option means we're cleared to make a touch and go, low approach, miss approach, stop and go. Cleared for whatever our intentions were is what clear for the option means, right? So we could stop if we need to. I mean, we still should be stating our intentions, right? If we're clear for the option, we say, okay, clear for the option, runway 23, Purdue 55, or whatever the case may be. If we're going to be stopping, we need to tell them, okay, clear for the option, this will be a full stop, right? It's very, very important to let ATC know what's going on, as we've talked about before. But those are what those vocab words mean, and then we can expedite, which is we need to do this quickly, right? That's another vocab word that they'll use. Go around. This is important to know as well, because if we're coming in and let's say, I know there have been instances I've heard of where someone maybe when they're in the pattern, they're number 4 for the runway, and they see 1, 2, don't see 3, cut them off and base to final, right? Then someone's going to need to go around in towers and say, okay, whichever traffic, go around. And you need to understand what that means, which means, clean up the landing configuration and get out of there, right? And you need to make sure that you're out, you're taking off and you're not landing, right, in the desired runway, right? Identification. So, right, this is a common one outside of the Delta, right? We make our 10-mile call or whatever. We say all our things. Then we come in and they say or Purdue 55 ident, right? There's a little identification button on our aircraft, and then you click that button. It's able to identify. Tower is able to identify from them directing you to click the ident button or saying ident, and then you clicking that identification button to know where you are, what your altitude is, all this information that they need to know. Another word, maintain, right? Maintain is something where and an altitude that's a common. Maintain 3,000 or whatever these things. They'll tell you what to do, and maintain means to stay at wherever you were in that scenario. Negative, also self-explanatory. No, we can't do that. We won't do that. Don't do that. Whatever the case may be. That is not correct. That is a big one. Like if you make a readback and you say, okay, for ground specifically, you say, oh, they told you to hold short at alpha, so, Purdue 55, taxi to 28 via alpha, hold short at alpha, and we say, Lafayette ground, Purdue 55, taxiing to runway 28 via alpha, crossing 23 at alpha. And I'm like, no. We didn't clear you to cross that runway. They're going to say negative, right? No, we did not clear you for that, right? So that is a scenario where negative may be in effect. Pilot's discretion, right? Another vocab word of pilot can do whatever it deems necessary, right? Pilot's discretion, so at your leisure, at whatever you decide, go ahead, right? That's what pilot's discretion means, right? Radar contact means ATC has been informed and has made contact with a specific aircraft, or has contact with a specific aircraft. Radar service terminated is the opposite, and instead of being in contact, that means, okay, we're no longer going to help you, right? Let's say Purdue 55, when whatever happens, radar service terminated, pilot's discretion, right? Those are usually two terms that are used together, right? Radar service terminated, which means ATC is no longer providing you any services, right? Roger, again, it's positive. It's saying, okay, I received everything. Roger, good. Say again, self-explanatory is you didn't hear necessarily what's going on. You need it to be repeated, whatever information it is. Squawk is the code that ATC will give you for any specific flight following or IFR departure or anything of that sort. Is the code that you'll put into your transponder is what a squawk. So when I say squawk, 1, 2, 3, 4, you're going to enter that squawk code into the transponder, right? So those are important. Squawk VFR, what that would be is it's a specific frequency, is 1200, right? 1200 is the VFR squawk code. So when they say squawk VFR, they're not going to tell you squawk 1200. They're going to say squawk VFR. You need to know what that means, right? Standby means hold up, wait a second, take a deep breath. Let me figure this out, right? And give me a second is effectively what standby means. Traffic advisory, it's advising you of traffic, right? It's traffic 2 o'clock, being the numbers, or looking for traffic in sight. Those are all traffic advisories, right? Traffic no factor means the traffic you were following is no longer a factor. They're no longer going to take part in or be in a way effectively of your stated intentions, right? Unable, we're not able to do something. So as a pilot in command, you can always say unable. If they say a common one is, to make a landing short of 2.3, so we're coming at 2.8, they'll say, can you make this landing short of 2.8? If you say unable, right, they can't give you something that you're not able to do. So you always need to understand, or if they say unable, that's something that cannot be done, right? Or when able, they'll say, okay, like squawk this code when able, or whatever the case may be. They'll tell you whenever you are ready, do this is what that means. Phonetic alphabet, again, that is something that I will assign as homework. I will not necessarily walk through step by step every letter of the phonetic alphabet with my student. That'll be something that, again, will come with practice, will come with time. I wouldn't expect to come in the first go of things, especially with everything else that's being thrown at them with communications. But it is definitely something that they'll need to know, and it is something that we will practice, and I will not necessarily hold their hand through. I will help them through. I mean, I'll be more than supportive, but that is not necessarily something that needs to garner my attention when I can allocate it to other more complicated scenarios where I can help the student. So the numbers is also very important when we're making like saying altitude route or something of that nature. We say at 500, right? So any of the hundreds, saying it straight up, 500 is good. Thousands, do not say something along the lines or to the effect of 1,500 or 2,000 or 2,500 or 6,500 or whatever the case may be. You have to say the first number in and of itself. So that number before the comma, you say its number, right? And that'll be more important even in the tens of thousands. So anything before the comma, you say individually, right? So in thousands of feet, right, it'd be 4,500, not 4,500, 4,500, right? And same for 10,000s, right? Everything in front of the comma, you're going to say individually, right? So if we're at 12,500, we're going to say 12,500, right? Not 12,500. So that's an important distinction to make as well. It's kind of a nuanced thing, but it's definitely something that we should take into consideration, right? And for frequencies, whenever we're making frequency calls for a tower, let's say, which is 119.6, right? Whenever they say, switch to 119.6, they're not going to say 119.6. They're going to say 119.6, right? And that's very important. They're going to say each number individually, right? Because it's very, very important that you get the frequency right, because if you get one number off, you're on the wrong frequency. So that's why this is even more important to get every single digit as it should be, right? So, and another important thing is say point whatever the number is, right? That decimal is also important. So you say 119.6, right? It's important to emphasize that point. That point is also a part of the frequency change or the frequency call, right? Whatever it may be. Directions, again, for magnetic headings or course headings that were given, you got to say every single number. Same thing. If you're one digit off, right? If they say, go heading of 045 and you hear 45 degrees or whatever, was that 55? Was that 65? That can... In the case of, you can be completely off of your waypoint. You can be completely off of where you're trying to go, where you're directed to go, and go into situations that you are maybe being directed out of, right? So understanding each and every one of those numbers is going to be very, very important to our operations. Same thing with runways. Runways are each number, right? So if you hear, let's say there's a scenario where you hear 23, and you confuse that for 28, then you're crossing 2-3 at alpha to get to 2-8, and that again causes all sorts of problems. So make sure we're using each of those individual numbers when regarding and speaking of runways, right? Transponder code we already talked about. VFR code is 1200, right? Is that VFR squawk code. For IFR plans or VFR flight plans or anything of that nature, they'll give us a number for their identification purposes. And then 3 squawk numbers that are very, very important for us to understand in emergency situations are 7500 or 7500, 7600, 7600, and 7700 or 7700, right? And those are important because those are, when we're in a specific dangerous situation, we need to know which squawk code to monitor, right? So those are emergency squawk codes, if you will. So for a hijacking, right, is 7500, or 75 taken alive is a way that a lot of people like to remember it. Remember that transponder frequency is that little rhyme, if you will. 7600 or 7600, that's comms failure or an other non-critical event, right? So the memory aid for that would be 76 in a fix, right? Like, oh, we're in a pickle, we're in trouble, right? Our comms aren't working, right? And then for those comm failure instances, right, we'll squawk that code, right? And for a controlled airport, we'll come to the airport 500 feet above a pattern circle, and we'll wait for light gun signals, which we'll talk about in a second, right? But in order for to understand that situation we're in, part of, other than the circling, part of their identification of that is squawking 7600. So remember 76 and a fix. 7700 is an emergency situation, right? And again, the memory aid for that would be 77 going to heaven. So in a situation where we could potentially die or it's a life-threatening situation, we're going to want to contact 7700, right? So in addition to contacting 121.5 in an emergency condition, we're also going to want to squawk at 7700 or 7700, right? So those are other transponder codes that we should know. And declaring for an emergency in a distress condition, fire, mechanical failure, structural damage, anything of that sort. We're going to use, whenever we squawk that code, whenever we get on that frequency, in those extreme conditions, we're going to say Mayday, 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 so people know what is going on and exactly what our predicament is. That's another identification feature, like, oh shoot, like someone's in trouble, right? If we're saying Mayday, Mayday, Mayday. And something that's not a distress condition, but is still urgent and is still something that you want people to know what's going on, you're going to say pan, 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 right? That's what you're going to say on the frequency. So that's in conditions like low fuel, a cloud that could affect, or not a cloud, sorry, any condition that could affect safety but is not necessarily a distress situation, right? Or something as nuanced as a sick passenger or something of that sort. So when we're in a situation where we're saying Mayday, 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 or pan, 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 we want to say as much as we can and give people who it may be applicable to, or people who can help us, as much information as possible, right? So in a scenario where we're going down, right, our engine's failed and it's in the winter, we want someone to find us as quickly as possible because we don't want to freeze to death, right? So give them directional information, give them the name of the stations, whatever station we're on, our aircraft type, so they know what they're looking for, the weather, the nature of the urgency, right? The intentions of what we're trying to do, or altitude, fuel remaining, any of those things. We want to give them anything that is useful for, in a Mayday situation, for them to be able to find us, and in a pan situation for them to be able to help us, right? So those are all things that we should be addressing as we use those frequencies and use those squawk codes, right? And in a situation where, in a 7600 situation, right, or 7600 comms failure, right, and we're not able to communicate with people, it's important to know how we can communicate without radio communications, right? So in a scenario where we're at an airport, right, we lose our comms, we lose our radio, we're at a delta. It's important that they know what we're doing because it's a controlled airspace and we can't hear their directions, right? So what we can do is, like we said earlier, we get to the airspace, we circle at 500 feet above pattern altitude, squawking 7600, right? And this is where they're able to communicate with us through light gun signals, because hopefully we can still see at this point in time, when we'll be able to see the intentions that they have for us, right, and the directions that they have for us. So again, this would be a homework item. I will walk through it, but this is something, again, will come with practice. Not necessarily practice. Hopefully we'll never necessarily need to be in this situation, but will come from quizzing and come from continued refreshing of this knowledge. I know, full disclosure, I know that I have even tended to forget these at points. And it is very important to safety of aviation, and it is something that I need to be freshing up on and making sure that I am aware of what these things say. Because in a dire situation, if I were to mix up, let's say, a flashing red light with a steady red light, right, that can cause all sorts of issues, right? When I'm in a steady red light on the ground, it's stop, right? And in a flashing red light where it's taxiing clear of runway in use, right? Those are very, very different things that we need to understand, because if we mix them up, that could cause problems, right? So for a steady green situation, I'll list these off very, very quickly. And there's also a compartmentalizing them on the ground and in the air, right? So on the ground, steady green will be clear for takeoff, and in the air, be clear to land. So clear for takeoff, clear to land, steady green, right? Flashing green on the ground is clear for taxi, right? So you can taxi. And flashing green, if you're seeing it from the air, means, hey, come back, return for landing, right? Steady red on the ground, stop. Don't do anything. Just stay where you are. Stop. Don't go anywhere. For whatever reason, there might be, if you don't have comms, there might be something else going on that definitely might be something else going on that you're not aware of, right? A steady red in the air is give way to other aircraft and continue circling, right? So maybe there's other aircraft that are approaching, or other aircraft that aren't in the pattern that necessarily maybe have priority, or maybe are closer to landing or whatever the case may be, and they're saying, okay, give way to that traffic, continue circling, right? Is what the flashing, is what the steady red in the air means. The flashing red on the ground is taxi clear of runway in use, right? So wherever you are, get away from that runway for whatever reason. And then flashing red in the air is airport is not safe, do not land, right? And flashing white is only applicable to ground. It's only applicable to ground operations, right? So seeing a white flashing light from the air, it's not, that could be the beacon for all you know, right? That is not for air traffic, as for traffic on the ground. And for the traffic on the ground, for the white flashing light is return to starting point on airport, right? So go back to where you started. This is what the white flashing light means on the ground. And an alternating red and green is the same for both the air and the ground, which means exercise extreme caution. So maybe there's something going on, again, we're not aware of because we don't have comms, right? There might be an accident, there might be high traffic, whatever it may be. You need to be exercising extreme caution in those scenarios for an alternating red and green flashing light. And then for the communication, some things that might help, switch from COM 1 to COM 2 in a situation that might, the COM 2 might be working in the case the COM 1's not. Plugging in your headset on the other side. I know I've been in situations where I've taken buddies up to fly and they'll put their headset, they'll plug it into a headphone jack, maybe in the back, and it's not working. Well, we quickly realized that if you plugged it into a different jack, it would work, right? So it's not necessarily a communication failure. It's just, especially in older planes, something that that might be an issue, right? Is the jack itself, and not necessarily the communication system as a whole. Going back to last frequency, so maybe when we were picking up the frequency, you tuned in that improper frequency, right? And we were like, if we were trying to contact, if we're coming into Lafayette ground from tower and we're taxiing off the runway, and we're at taxi off the runway at Bravo, right, or something of that sort. And we tune in, and let's say we're not from this area, and they tell us, contact ground at 121.9 or 121.9, right? And we say, okay, we'll contact ground at 122.9, right? Or 121.7 or something like that. Then we'll be tuned into the wrong frequency. So sometimes the best thing to do is to go back to that previous frequency and affirm the frequency that we're talking about. Or the frequency that we were supposed to communicate. Checking the volume on your headset or on the avionics. That can also be something that for whatever reason is turned all the way down. We know that it's just a user error, right? We just need to turn up the volume. Again, we talked about the procedure, going to the nearest airport. Non-towered airports we want to avoid because we want to avoid that traffic, but for towered airports, circling 500 feet above pattern altitude until the tower notices and gives us these light gun signals, right? Common errors, using the wrong frequency, kind of already talked about that, which it can usually occur when switching between frequencies, we pick up the wrong frequency, right? And the way you can mitigate this is to switch back and confirm the frequency that we should be on with the prior controlling agency, right? Recognition. If we're given a frequency and there's no response, we need to make sure we're letting them know we have the information that they've given us. We have to recognize when they give us a command. We have to recognize when we're cleared to land. We have to recognize when we're cleared to take off. We have to recognize a variety of different situations. If we're not recognizing, they don't know that we have the correct information, that we know what is going on. That is really all that I have for comms, radio communications, and light gun signals. At the end of this, I would maybe run through with my student, we're coming in to Lafayette, how to make the call. Sorry, another phone call. I lost my track of thought. I might run them through how do we make a call, right? And how those things work, and like who we are, run through that acronym and that list of things, and just make sure that student is able to at least work through with me how we would do those things. With that being said, that is all that I have for today. Thank you so much for listening to this presentation. See you next time, I guess.